All right, here we go. Section 8.4. We're talking about area of regular polygons. So here we have a regular pentagon. All the sides are congruent, and consequently all the angles are congruent. And we're going to use this regular pentagon to kick off our investigation of the formula for area of regular polygons. So what I'm going to do, I'm going to take this regular pentagon and I'm going to break it into some triangles. So I'm going to go from, that point right there, which, we could sort of call the center of the pentagon. And then I'm going to go here, and I'm going to go here. I'm just creating a segment from the center out to each vertex, right? And so each of these segments is congruent to one another. So let me just mark them as being congruent to one another. So what we've now created is 5 congruent isosceles triangles, right? And that center point is actually the center of the circumscribed circle. So let's do this. Let's bring up our compass here, rotate it around, put it on that center, and measure out to one of the vertices. And about right there might be as good as I can get. And now I strike the arc or the circle, and you can tell that that is the circumscribed circle, right? So the center of that regular pentagon is the center of the circumscribed circle. And we have 5 congruent isosceles triangles. Now, if we can find the area of one of these triangles, then we can multiply that area by 5, and we will have the area of the entire regular pentagon. So this is the approach that we're going to take to find the formula for the area of any regular pentagon. Now, before we can find that formula, we have to define the apothem. An apothem of a regular polygon is a perpendicular segment from the center of the polygon's circumscribed circle to a side of the polygon. And you can see in the diagram, there is the apothem, that blue segment. It's perpendicular to the side. And you must be careful that you do not mistake an apothem for a radius or a radius for an apothem. So let me draw this in. So it's very common for students to mistake the radius of that circumscribed circle, which sometimes we call that the radius of the regular polygon. Sometimes students mistake that radius for the apothem. Obviously, you can tell that the apothem is the segment perpendicular to the side, whereas the radius is the segment to a vertex of the polygon. Okay, so keep those two things straight. All right, now that we've defined the apothem, let's go and create the formula for area of a regular polygon. All right, we're going to start with the regular pentagon up on the left. You can see there's a diagram very similar to the one that we had just a minute ago. They've labeled the apothem, it's drawn in there, and they've labeled the side length right there. That's an S. Okay, it might be a little bit hard to see. So the length of each side of this regular polygon we are calling S, and we're calling the length of the apothem A. I'll just write that in there so it's a little bit easier to see. All right, so let's find the area of each isosceles triangle. So we know the area of any regular triangle, 1/2 base times height, right? Well, if we're finding the area of this triangle right here, then the side length of the pentagon is the base, and the apothem is the height. So 1/2 base times height becomes 1/2 side length times apothem. Now, if we want to find the area of the whole regular pentagon, we're going to multiply this by 5, because there are 5 congruent isosceles triangles. So we'll multiply by the number of sides, in this case 5. All right, let's go to the second one, the regular hexagon. So you can see there are 1, 2, 3, 4, 5, 6 congruent isosceles triangles now. They have labeled each side length S and the length of the apothem A. So if we want to calculate the area of one of those triangles, 1/2 the base, which is S, times the height, which is the apothem, and now to find the area of the entire regular hexagon, we would multiply by the number of triangles, which is 6. All right, let's go to the regular heptagon. Same approach, right? We have a side length of S. We have an apothem length of A. We have 1, 2, 3, 4, 5, 6, 7 congruent triangles. So let's find the area of one of the triangles, 1/2 the base times the height. Now the area of the entire regular heptagon will multiply that area of one triangle times 7 because there are 7 congruent isosceles triangles there. So we're starting to see a pattern here. To find the area of the regular polygon, we're going to take 1/2 times the side length times the apothem times the number of sides. We'll call that n. 1/2 SAN. Now let me rewrite that as 1/2 ASN. And here's why. Because if we take the side length times the number of sides, think about that. The side length times the number of sides. Right, so let's go up here. The side length times the number of sides is the perimeter, right? So we also could rewrite this formula, 1/2 ASN. We could write it as 1/2 the apothem times the perimeter. So we now have two different formulas for the area of any regular polygon.